RAID, Redundant Array of Independent Disks, is a data storage technology that combines multiple physical disk drives into one or more logical units to improve performance, increase storage capacity, and provide redundancy, protection against data loss. Here are the common RAID types. RAID 0, striping. Data is split into blocks and distributed evenly across all drives. Advantages include improved performance with increased read and write speeds and full storage capacity of all disks with no overhead for redundancy. Disadvantages are that there is no redundancy. If one drive fails, all data is lost, and it is not recommended for critical or important data. Minimum disks required. 2. RAID. 1. Mirroring. Data is duplicated, mirrored, on 2 or more drives. Advantages include high data redundancy. If one drive fails, data is still available from the other, AUS, and RAID performance can improve since data can be read from multiple drives. Disadvantages are that storage capacity is halved, e.g., two 1 TB drives give you 1 TB of usable space, and write performance might not improve. Minimum disks required. 2. RAID 5, striping with parity. Data is striped across multiple drives with distributed parity, error checking information. Advantages include a good balance of redundancy, performance, and storage efficiency, and it can withstand the failure of one drive without data loss.
RAID 6, striping double parity. This is similar to RAID 5, but with 2 sets of parity information, providing extra fault tolerance. Advantages include the ability to withstand the failure of 2 drives without data loss and a good balance of redundancy and storage efficiency. Disadvantages are that write performance can be slower in RAID 5 due to additional parity calculations, and there is increased storage overhead compared to RAID 5. Minimum disks required. 4. RAID 10, 1+0 mirroring plugging. This combines the redundancy of RAID 1 and the performance of RAID 0 by mirroring data and then striping it across multiple drives. Advantages include high redundancy, can withstand multiple drive failures, as long as not both drives in a mirror set fail, and high read and write performance. Disadvantages are that it requires a minimum of 4 disks and storage efficiency is 50%, like RAID 1. Minimum disks required. 4. RAID 50, 5+0 stripe of RAID 5. This combines RAID 5 and RAID 0 by stripping data across multiple RAID 5 arrays. Advantages include providing the benefits of both RAID 5, redundancy, and RAID 0, performance, and can tolerate 1 drive failure per RAID 5 array. Disadvantages are that it is a more complex setup and management and requires at least 6 drives, 2 RAID 5 arrays of 3 or more drives each. Minimum disks required. 6.
RAID 60, 6+0, stripe of RAID 6. This is similar to RAID 50, but with RAID 6 arrays instead of RAID 5, adding double parity. Advantages include greater fault tolerance than RAID 50, can tolerate up to 2 drive failures per RAID 6 array, and a good combination of performance and redundancy. Disadvantages are that it is more complex and requires at least 8 drives, with higher storage overhead than RAID 50. RAID 2, 3, 4, legacy or rarely used. These RAID levels are based on variations of striping with dedicated parity, or ECC, error correction codes. They are rarely used today due to their inefficiency or reliance on specialized hardware. Other RAID variants include RAID 1E, a hybrid RAID 1, and RAID 0, where data is mirrored across pairs of drives and then striped. It's less common. RAID 7, a proprietary RAID level developed by Storage Computer Corporation, using caching to improve performance. It's not widely supported. RAID 10E, an extension of RAID 10 with some parity and caching improvements. JBOD, just a bunch of disks. This is not technically RAID, but simply a configuration where multiple drives are used independently, without any redundancy or striping. Data is stored across multiple disks, but without any RAID features like mirroring or parity. Each RAID level offers a different trade-off between performance, fault tolerance, and storage capacity, so the best choice depends on the specific needs of the user or system. Dynamic disks are a type of disk configuration in Microsoft Windows operating systems. offering more advanced features than basic disks. They allow for more flexible storage configurations, such as the creation of volumes that span multiple disks, which is useful for larger storage needs, improved performance, or fault tolerance. Dynamic disk types include several types of volumes that can be created on dynamic disks. These volumes differ in how they organize data across multiple physical disks. The main types are simple volume, which is the basic type of volume that spans a single dynamic disk. It behaves similarly to a partition on a basic disk, but allows for better management features and can be extended onto other dynamic disks, but only after conversion to another type. It is best used for a single disk setup or for simple storage needs. Key points include that data is stored on one disk and it can be extended if more disk space is added, but only if the space is unallocated and available on the same disk.